What's going on, everyone, and welcome back to another tutorial. So, in the last episode, we kind of got camera halfway, uh, about halfway set up, the actual camera class itself. And we got the ability to move the editor camera around with, W and S. So we can just see that the editor camera or vector actually is moving, and you can move throughout the scene. Now, in this episode, we are going to do multiple things, very complicated things, and yeah, kind of makes it a little difficult. I recorded this a couple times before, and just like what a couple other previous episodes, I just ran into problems. So whenever I recorded this, uh, at one point, even during the recording, I'm sitting here trying to figure out what I'm gonna do, and I ended up making it where it deleted my entire scene. So yeah, so that was a big problem, and I'm sitting here in the middle of a recording, like, what in the crap just happened? That is horrid. So what I'm doing is I went ahead and finished it because I don't want to go through the or go through the episode and accidentally have something like that happen again, because the things that we're tinkering around with right now can can screw some things up if we don't do it perfectly. And as you probably know, with other episodes or other series from other people, you'll notice that not a lot of people go over layers or multiple cameras and stuff like that, and it's because it's so complicated. Um, yeah, so another thing you're going to notice is, well, you can't notice it right now because it's not even up there, is key code. I added this key code class. So what this class is, it basically just tells us what the key code values are. So keypad 5 would be 325 and so on. GLFW has its own built-in method, so it's not really important if you don't want this script. You don't have to. This was something I already had pre-done even before I started recording the other times, and it's because it's not essential. It's just something that I like to do. So what I did was I went through the Unity documentation for key code, and I copied down all the names and whatever keys that they're using in their key code, just to make it easier for people who uh, want to look up documentation or whatever, finding an exact name or whatever the case may be. Instead of me writing my own documentation for it, I can just point you to Unity's documentation for key code, and it's even written in the same order. The only difference really between this and GLFW version is I have things like hash, dollar, percent, ampersand, left parentheses, asterisk. It's not really important to have those things, but they're in there. So there's a lot of extra stuff that GLFW does not provide. And there's two things that we cannot use, well, just because of our implementation of it. Um, for instance, pipe, just the up and down line, is 16,777,340. That is the actual key number for a pipe. And this is 342. and we actually go to 64,400 and whatever. So we don't even go up that high. So I've got it in here, so just in case you want to use it, you would have to figure out how to use it, but I've just got them commented out. Another thing I don't have is, of course, uh, Mac keys and stuff, because, well, I don't have a Mac, so it's kind of hard for me to tell what the key is if I can't even test the value. I also have mouse up here for mouse 0, left click, right click, middle click, so on. And joystick buttons set up just like Unity as well. The biggest issue I have with Unity's version of joysticks, though, is like joystick button 0 is 0, joystick button 1 is 1. So kind of doesn't make sense, but it's still there. And we're not going up to 19 because, well, I only have sticks that have 15 buttons. So I can't really go up any higher. I think that they said that it only goes to 15 anyway, so. And we'll actually be handling multiple joysticks in the input class, not the key code class. So whenever we get around to joysticks, like having multiple controllers, split screen, all that crap, we'll be doing that in the input class, not in here, because that wouldn't make much sense. We're just going to make a function in the input class for checking joysticks. So it'd be like if input dot joystick, and then you would have pass in the joystick that you want, whether it's the first controller, second controller, or whatever, and then whatever button it is. Hold on just a second. Sorry, once again had a kid at the door wanting to play a game. Alright, so that is it for key code. I will supply it in Patreon as a free download, so you don't have to pay the dollar or whatever, because it's nothing really important, just if you want to use it. Alright, so let's get into this complication. So whenever we're dealing with layers, we have to do it at the same time as we're doing multiple cameras, or even cameras in general, if we're going to be using layers at all, which in this engine we are using multiple layers. We're using multiple cameras. So I added a little bit onto the camera class. So if you open up the camera class that we did last week, all you're going to do is you're just going to add this little variable right there. Yeah, that's the only thing I added in here. So this is just going to tell us what layer we're going to be rendering on. Now, how I have this set up is inside of the renderer class, we have the amount of layers that we can use. Now, since it's a 2D game and not a 3D game, we don't really need a whole ton of different layers. So open up your renderer script, and right here up underneath FBO, just write private static int layer count. So since we're in a 2D game and not a 3D game, and we're not using hellacious amounts of layers, I'm just going to restrict it to 8, because I think 8 in itself is probably more than what we're going to need, but it's still there. And underneath it, I wrote private static int I. That's just a iterator variable, just like how we always do it. Just for whenever we're looping through these different layers. Now, the complicated part right here is, uh, right here, this is our code from before. So before we were just batching a material with a list of sprite renders, which, bam, worked perfectly. But the issue is whenever we're working with layers, we have to have a list of this stuff because you know, each layer has its own independency on whatever's being rendered onto the screen. So if we're rendering layer 0, then we can only render objects that are using the layer tag or layer 0. So here is the new code right here. So it's basically just this private static list of maps, material list of sprite renderer, and just named it render layers, and of course initialized it to a new array list of map material list of sprite renderer. So I'll just go ahead and get rid of that because we don't need that anymore. Alright, so that's it for this part. Now, in the initialization function of renderer, right here, what I'm doing is I'm creating a loop. I'm looping the amount of layers that we want. So we're looping through layer count, which is how I set it at 8. You could do whatever you want. You want to do 2, that's fine. 1, that's fine. It's whatever max layer count you want. The least amount of layer counts, the faster it's going to run. Bloody freaking blah. And then we're just saying layers.add new hash map of material list of sprite renderer. So we're basically just initializing it to a new hash map. All right. So add to renderer has also changed a little. Oh, right here. We also need a public static final int layer count, return layer count. Since we have it private, because we don't want anybody to change it, so that whenever we create our game or whatever, we don't want this public, because if somebody comes in and messes with it with some program or whatever, they can change the amount of layers and whatnot. So we're just all we can do is just get it as a final integer. All right, so add to renderer. So this is the new method. It's basically exactly the same. All of this is pre-existing code already in your method. So what I did was just scooted it down a little bit, and then I added this line right here, which is basically doing like what we did before up top whenever we had an actual batch variable. So I'm just saying map material list of sprite renderer batch equals render layers dot get r dot game object dot get layer, and all that's doing is just getting the layer of the current game object. So really quick, we'll go over to game object after you type that up, and inside of here I added a layer right here. So it's private int layer equals 0. And I'm keeping it private because we're actually going to have in our editor be able to manipulate that, but we want to keep this 0 or this layer between 0 and the maximum amount of layers. That's why we're keeping that private, because we're going to have the editor do that for us. And then down here, it's just a basic getter and setter. So public final int get layer return layer, and public void set layer and L, and then I'm just doing a mathf.clamp. So I clamp it to 0 or the maximum layer. Actually, I did this wrong. Maximum layer minus 1, because the maximum layer is whatever I set it on, 8 or whatever, but we don't want it to go any higher than 7, because, well, 7 is 8. Alright, so after we clamp that, let's see here. Did I add anything else into here? I know that I actually changed a few things as well, because the issue that actually deleted my entire scene when I was recording the first time, I had to go in and fix that. And then I had to redo another scene and add variable stuff to the editor, and we'll get to that. It was a nightmare. But as for the game object class, I think I might have added, prepared to render. Okay, yeah, this right here is new. Before on yours, with you looking at it, it's all going to be one line, and at the end of the line you're going to see this right here, render.add to renderer, and then it passes in this value right here, sprite renderer component. Well, we want this right here, because what the issue with this is whenever it deleted the scene, and then I went to put another sprite renderer on there and add a sprite to it so that I'd have something to look at, it actually shut down my application because the sprite was null inside of the sprite renderer, and that's why we're adding this. So that fixes that. So now we can have a sprite renderer with a null sprite on it. So I'll remove that right there. So it only adds to the renderer if there's a sprite. Let's see. Yeah, that is it for game object. Let's go back to renderer. All right. Now here inside of the render function, basically a lot of this code is the exact same code that we had before that you guys have. So it's this code right here is what you already had in there, outside of the camera loop, of course. But right here, we're getting the list of cameras from the camera class. So we're saying list cameras equals camera.cameras, and then we're looping through all of the cameras. So we're looping it with camera.size. And then the first thing that we're going to do inside of this loop is we need to get the actual camera. And since the camera layer is public, I had to add a mathf.clamp function. For the moment, we'll probably change it later, but we'll have to mess with the editor a little bit more so that we can actually view it and stuff like that. So at the moment, we're just going to keep it public so that we can change it. So c.renderLayer equals int mathf.clamp, and then clamping it from 0 to layer count -1, just like how we did earlier in a script. And right here, all we're doing is we're just getting the batch for this camera. So the batch is equal to renderlayers.get c.renderlayer. And then right here, we're just going to do exactly like what we did before. Loop the material and all that. Let me see here. Material. Okay, so nothing really changed except for this right here. Above, erase this later where I put that comment. If you put that comment as well, it'll say material.shader.set or else material.shader.set uniform campos, and then we're setting it to vector 200. Well, we're not setting it to 00 anymore because we actually have a camera to get the position off of. So we're saying material.shader.set uniform campos c.gameObject.position. So then that'll pass in the actual camera's position. And then before, right down here, it said, in this place it said batch.clear. And we're basically replacing that batch.clear with this code right here. So we're just looping through all the render layers, and then we're saying render layers.getI.clear. And that's clearing the batch for it. That was already on there. Okay, and that is it for the render class. Let's see here. Why did I have Scene Manager open? Oh, that's right, because I had to manually write in the parent because we don't have a way to parent it without doing it in the actual file. That's right. Key code. Another thing that inside of the editor, I don't know if you guys wrote this too or if it was just me who did this. Down inside of write transform game object G file writer FW, I had this writing it to g.position.x and g.position.x. So I had to change that to a Y, and I had to change this g.scale to a Y because both of those were X's for some reason. So if you did that as well, then you might want to change that. Save scene. Let's see here. I know I added some stuff on editor. Yeah, there's a lot of stuff that had to be edited. As you can probably tell. All right, now as for dragging the camera around, this is how we had it before. We were basically just checking if we were hitting W, if we were just increasing the position of it. Well, we can get rid of that. We don't want that no more. What we're going to do is in the variables, we're going to need 3 new variables. It's going to be static byte dragging scene, and it's going to be set to 0. Then we're going to need vector 2 start drag point, and then it's going to be equal to new vector 2, and that is the whenever we click, that is the position that we click at, not the position that we're dragging at. The position that we're dragging at is actually mouse dot position, and we're just using the start position to calculate how far we're actually dragging. And we also need a private static vector 2 start camera drag point, which is just going to be equal to camera position for now. And then down in the render method, right here, we actually need the scene area. Oh, so that's another variable that we need to create is scene area. So right up here at the top, just put public static rect scene area equals, and then just a new rectangle because we're going to be setting that. And then right here, we're going to say scene area dot set, and then here is our default window. This is basically where the actual scene is being rendered at. Now, whenever we get to adjusting the size of everything so that we can click on it and then adjust the size in real time, this is what we're going to be changing. So we'll be changing the scene area, and then down here will be we'll just get the values off of this rect. So just make sure you put that down. So 430 application.width minus 800 and application.height minus 260. So then what we're going to do is we just check to see if the mouse position is currently inside of the scene area. And if it is, then we need to check if we click. Now, if we click down, what needs to happen is we need to set the drag or the start drag point to equal mouse dot position, because that is where we clicked at, and then set start camera drag point to equal camera position, and then set dragging scene to 1, just like how we do booleans or whatever. And make sure that this if statement right here is outside of this if statement. We want it separate. Don't put it right here. Because if you do that, then what happens is if we let go outside of the drawing area, then this would never catch if it was inside of this if statement. So we want it to catch regardless of where the mouse is whenever we let go. So what we're going to say is if dragging scene equals 1, so if we're dragging, then the dragging distance is going to equal start drag point dot sub for subtract mouse dot position. So we're just saying, well, start drag point minus mouse dot position. And the camera position is going to equal start camera drag point dot add, and then we've got to separate this. Like, even though we've got the variable and we can pass in the variable saying drag distance, we have to negate this y because of the way that we draw things. So we have to say drag distance dot x negative drag distance dot y. And then right after that, we check to see if our mouse button is up. So if mouse dot get button up 2, then dragging scene is false or equals 0. So 2 is of course the middle mouse button. Now Let's make sure everything is done out of here. Oh, okay, there's one I had to change. Where are you? Oh, we already went over that. It was Y instead of X. Camera position. Okay, here's another thing that we had to do in here. So down inside of right component, we need to come all the way down here, and this line right here, this if statement is new. So before, what your code looks like is that. What it needs to look like is, what in the world? Okay. What it needs to look like is that. So it needs to be else if f.getB does not equal null. Because I was having some issues with it being, or a value being null. So if it does not equal null, then we need to actually add to that line. So nothing big right there. Just that's just a catch. If you do not put that right here, you're not going to be able to go into play mode. As soon as you go into play mode, that's when it deletes, and it will delete your scene. So yeah, pay attention to that. All right. Don't need that anymore. Don't need that. Okay, core. I just copied this rect right here off of core to find my actual render position. Okay. Okay. Let me highlight that, and we'll get back to that in just a second. Gotta just make sure that there isn't anything on here extra that I added. I don't believe there is, but it's always safe than sorry. Okay. So here is something else that I added. I added the ability to add sprites at runtime. Apparently before I forgot to do that, so I went ahead and added it. It's basically just allows you to click on a sprite variable in the editor, and then you type in whatever the name is for the sprite, and then whenever you hit enter, it's going to find it, and then it's going to attach it to that variable. So we're going to say it's going to be above the else statement. So it'll say else if split1.equals sprite. And then what we're going to do is do like how we did before and say ba.c.getDeclaredField split 0. That is our field variable. And then here we're actually going to get a sprite out of it. So we're going to say sprite equals sprite, because we're casting it to it. s.getBA.behavior, and then here's our p variable, so string p equals empty, because if it's null, then it's going to stay empty. If it's not, then we're going to get the name. So if sprite does not equal null, then p equals sprite.name. And then right here, we just paste the variable, which is the exact same vector that we're using right here as well. And right here we will say if not p dot equals v, then s dot set ba dot behavior sprite dot get v. So instead of doing like the other ones and just setting certain variables, we actually have to get the sprite to set it. And then, of course, the normal stuff, like how we do all the other ones, the catch down there. And that is absolutely it. You think all that stuff that I did, it's been 35 minutes. Imagine how long it would have taken if I would have recorded and did it at the same time. All right. So now, whenever we run this, we'll take a look at some of the things that this did. Now, of course, you'll see a new scene that I have up. I don't have it perfect. I just kind of threw something in there for now. But I wanted a new sprite sheet to work with for whenever I start building full-on scenes and testing multi-cameras and all kinds of crazy stuff. So, yeah, I needed a new sprite sheet, so I just went ahead and set up a little test thing. So if we click down with the middle mouse button, you'll see that we can actually just drag this camera around now. And this is our scene camera. And right there is the actual position. And that right there is 0 in this corner of this square. All right, so we can see that it's rendering and moving just like how we should. If we move it over here, if we hit play, should go back to the original position. Now, if you're having a problem at this point, then you obviously did something wrong. And I hope it didn't delete your scene or whatever, because I showed you what code actually deletes your scene. All right. Oh, I kind of forgot to tell you. If it does not render at all, then it's because you don't have a camera in the scene. Completely forgot to tell you, or forgot to mention that. So what you're going to need to do, I'm actually going to create a second camera right now, so you can just do what I do. So just new camera. And right here, for me, I'm just going to rename it to camera 2. You can just rename it to camera. Camera 2. There we go. Now click on add component, because we want to add a camera. So it is in the engine folder. Whoa. What in the world? Engine.camera, because it's a pre-built class. All right, so then that added a new camera, and here is our infamous render layers. So if I come here, I'm just clicking on camera. You don't need 2 cameras right now, just one. If it wasn't rendering before because you didn't have a camera in the scene, now once adding it, it should render just fine. So right here under render layer, this is all set. It's automatically all set to anything in the scene is automatically set to 0. So it renders on the 0 layer. So if we go under the render layer and we change this, let's change it to 1. Okay, it's probably because I have that Okay. Sorry, that was my bad. I had camera 2 rendering on 0 as well. Okay, so now we have no camera in the scene rendering layer 0. So since all these sprites in the scene are on layer 0, it's not going to render it. So if we set this to 0, it will render it again. Alright, I'm going to go ahead and set this back to 0 because I have something to show you at the moment. Alright, so the way that the code is set right now, it does not, like how this all renders in the editor, we're seeing the editor camera. We're not seeing the camera itself. So, of course, we're not going to see any difference. If I come over here to camera 2, if I change camera 2 to, let's put it on layer, or on Y, I'll put it at 64 because that's how high up this is. So if I put that to 64, you can see that it didn't change anything. And that is because it's the scene camera. You only see the scene camera if well, if you're in play mode. So eventually we'll add like maybe down here in the corner, kind of like what Unity does, like a preview or whatever of that camera if you click on something that has a camera attached to it. So you'll see like a preview of what that camera sees. But you won't see a difference if you move these cameras. But since I moved that up to 64, if I hit play, you'll notice that they're double stacked now. And that's because one camera is 64 units higher than the other camera, so it moved down. So we know that multiple cameras are working awesomely. So let's move this to 120. And there it is. So let's take a script. Where's the script at? Oh, I don't have that on there yet. Let me save this scene. And it should be in here. We're gonna test this out really quick. Scripts and play. Game object dot rotation. We're gonna say game object dot position and position. Yeah, why not? Just like that. So the camera will be in the update function. It will be slowly moving to the side. This needs to be dot mol. I think I've capitalized that. So we're multiplying its position by that. All right. So let's see if that works. First we need to attach it to one of the cameras. I'll attach it to camera 2. So we can just imagine that camera 2 is like a background layer or something. Oh, come on. My computer's being slow. There we go. And just add play. So now camera 2 has play attached, so it should move to the side at a slow rate. And it's not. GameObject.update. Let's say system.out.println GameObject.position.toString. Oh, I don't have it. Never mind, that's why. It's because I didn't have it, we don't have it updating yet. We have not added that. Because we went on to other stuff. And so that it doesn't automatically update the script inside of the engine whenever we change it. But we'll get to that eventually in the future. Alright, now play. And all it's doing is saying 0, 0, 0. Why aren't you changing then? Oh, because it's just moving back and forth. Duh. We need that dot mol. Dot add game object dot oh, duh. I was doing it all wrong. So GameObject.position dot add I think no. I'm a retard apparently. GameObject dot position dot add. There. So GameObject dot position, GameObject dot position dot add. Position. Okay, that should work. That should work. Let's try it again for God knows how many times. We need to add some more methods in there, so we have more to work with, like a move method or something. There we go. So whenever we run that, this camera is actually going at an angle. So you'll actually see it, this moving down. But this camera is sitting still. Yeah, so it is definitely working as it's supposed to. So as you can see that if this was, for instance, a like a platformer or something, and we had something all the way across, and then this camera is moving this way, then we would have the other camera moving slowly this way. So this camera is going to equal like 1% of this camera's X. So then everything in the background would just slowly move, while everything over here will move a lot faster. All right, awesome. So that definitely works. All right, well, guys, that is it for this episode. And I have no idea what we're going to be working on next episode, but hopefully it's something good. All right, well, thanks for watching, guys.